on his head right now.
Well, guess who has the brain cell today?
Oh.
Okay, determine the total number of possible outcomes if a coin is flipped and a number cube is rolled. So by number cube, I mean a die. So there's two events.
Yes.
How many things can happen if you roll or flip a coin?
Two.
How many things can happen when you roll a die?
6.
So how many combos of those can happen?
12.
2 times 6, yeah, 12. Number 2 is a tree diagram. Do you guys remember how to do that?
Yeah.
Oh,
Draw a
yeah.
tree.
So it's a tree diagram of number 1. So
201. Wait, where did she really stop at?
Yeah, she stopped at 200.
Sam?
Don't
we
stress me.
We should take bets on what she'll have by the end of the
We
year.
have a problem.
Sam?
I lost the paper.
It's gonna be
2, 2, 2.
Okay, so you know it's 200. So you
Yeah.
just write 200.
You lost
Sad, that paper's
Sam, you lost the paper?
Yeah, give me one of yours. I need both of them.
Sam, that paper was
Didn't he
saved.
start to
Yes,
give
I
it
don't
to
think
Trey
you
and then
can
gave it
redo
to
it.
Ava?
Yeah, I got it back.
The original one.
I gave it back. Don't even try to go look. I can't believe you lost it.
You have to find the original.
Just find it later.
He's like,
Well, it doesn't matter. There was 200 on it, so you just start over.
Right,
gonna
it's
talk
not
to
the
you.
same.
It's not the
2
same.
0. It's not the same.
it's not the same, Sam.
Who cares? Okay,
Sam's gonna cry.
Like, find it later.
so the first event is a coin flip. What could happen on a coin flip? Heads, tails. The second event is a die roll. What could happen on a die roll?
6.
1, 2, 3, 4, 5, 6. So off the heads, what could happen? 1, 2, 3, 4, 5, 6. And off the tails, same thing, right? So that's basically the picture. Oh, I didn't finish it, but and then you're supposed to say what are the possible outcomes. So one of the possible outcomes is getting a heads and a 1. Or a heads and a 2, or a heads and a 3, or dot 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 dot. And you should have 12 outcomes. Number 1 and 2.
I should probably have a book open.
Oh, yeah, heartburn.
I put a lot of sugar in it. Same as
Okay, so I know you guys remember putting that in the calculator, but what does P stand for? Pa-pa-pa-pa. Yeah, hey, you got it. Permutation. But more importantly, what did it mean? Like, permutations are used when the order ain't the other one. Order matters. So 3A would be 7, 5. So that would be like if I have 7 people in the race, and how many combinations can get like first through fifth? If the first 5 places get medals, how many ways could that happen? So the order matters because first is different than second, different than third. Okay, did you guys get that? So out of the 7 people, 5 people place. That would be an example for number 3. But you're supposed to plug it in the calculator. And then on B, it's a C. What does C stand for? This combination is what they call it. I kind of wish they used a different word because I like to use that word. Anyways, combination, the order does not matter. So that would be like, we're going to, the movies. So out of my 3 friends, 2 of them are going with me. So that would be a combination because there's no like a first place, second place. It doesn't really matter who's who. So that would be combination, order doesn't matter.
the problem is, guys.
Do you have a Dr. Pepper?
Maybe you're having
Wait, so are we
a
ready?
reaction to math class.
Are you writing this down?
You're going to need this no, you're not writing it down. You're going to need this information for the following problems. But number 3 is just like calculator problems, basically. Yours can do it too, though. Yeah. Did we find it on your calculator? It's in the PRB button on yours, probability button. Or maybe we didn't find it. I just know it from the other class. You see PRB?
I do. I don't remember doing it just
Maybe I didn't know where it was until the day after we did
Yeah.
it.
How many did you forget?
I don't know where.
You have to do,
I pushed the.
yeah, you want to do the first number first. I mean, before you select. So, yeah. And select that. So just to make sure you're plugging it in right, number 3A is like 2520. Yeah. I mean, it's, yeah. Number 5. So on number 4, it says how many different committees of 7 people can be chosen from a group of 10. So on committees, is there an order to the people? Does it matter? No. So that would be
P. Ooh.
combination. So out of 10, you're choosing 7. The bigger number always goes first. 10, choose 7. That's like, what are you laughing at? And I'm like, oh, okay. You got a problem. Number 5, how many different ways can the letters of the word mouse be arranged? Okay. So how many letters are in the word mouse?
5.
How many possible letters can be in the first spot?
26.
We're using the letter. We're using the. We're recycling the letters from the word mouse, not the alphabet.
Sounds so complicated. I need to go home.
Okay. How many letters could possibly be in the second spot? 4. Because we've already used a letter here. So it's, how many combos are there? You do that. Do you guys remember the button that could do that in one?
Like exclamation mark.
Yeah, it's called factorial, 5 factorial. You don't have to use that, I'm just saying.
Where is
One
it?
is 1.
It is one.
One's 1. The factorial button is right under your mode setup button.
Okay. We also, so does the order of the letters matter?
No.
Yes, because when you change the M and the O, that makes a different word. So the order does matter. You could have also done permutation 5 choosing 5. That would also give you the 1 point. You guys get it?
Yeah.
So they both work. Usually I did this, but since that section,
That's so funny.
Are you following the letter? Barely, yeah.
Okay, now Leo's having nightmares about this.
Dude, the middle child is
I didn't
always-
think it was gonna happen.
Like
I'm-
last,
Actually, I'm
I'm the middle and I'm the
I
shortest.
don't think it's gonna happen.
like last year, he was so short. He had like this high-pitched voice, and now I walk in his room, he's like, "Who Leo?"
That happened to you.
What's got you? You got
Like 6th grade, you sound like a little mouse, and then
No, I don't.
7th grade, you're like, hey. Hey. What happened over the summer, Leo?
Your face got longer.
That's not like helping.
He did. If we could have got a ruler out and measured it.
Sure, your voice didn't change. Shut up.
Shut up.
Yes, it did. It's the same as 4th grade.
All right. Number 7. How many 6 or 7 letter arrangements can be made from the word scholar? So scholar has 7 letters. So if we did 7 letter words, that would be 7 possibilities, kind of like the last problem. 5 possibilities. I didn't do enough spots. Okay, or if it's a 6-letter word, 1, 2, 3, 4, 5, 6. How many options would there be for the first spot?
7.
Still 7.
Just goes to 2.
It only goes down to 2, which actually doesn't change the answer. But, so this represents 7-letter words, 6-letter words.
You forgot 4.
No.
It's okay.
I was wondering why.
Yeah, I was about to figure it out. But it's this or this, so you can add those two probabilities together. I guess I'll put it right there. Those two number of outcomes together, I should say.
10,000 maybe.
Yeah. Again, we could have used permutations. We could have done 7, permutation 7, choose 7, permutation 7, choose 6, and added those together. That would have worked also. Number 9. Nevaeh flips a coin 20 times and gets heads 13 times. So she flipped a coin 20 times, she got 13 heads. What's the theoretical probability? We didn't really talk about these words, but what's the probability of flipping a coin and getting heads? Yeah, 1 in 2, 50%. That's the theoretical probability. So the experimental probability on number 10 is based on the experiment where she flipped 20 times and she got 13 heads. What's the probability, based on just the experiment, what's the probability of getting heads? 13 out of 20. So that's all they wanted for 10. Suppose the more you do something, the closer and closer it should get to the actual probability. So if you have a gigantic sample size, it should be very accurate to the probability. Number 11, a bag contains 5 orange, 3 purple, 6 blue tokens. So what is the total amount of tokens? 14. So the probability of getting an orange would be 5 out of 14. I thought I might get the death stare out of that one. Did not. You didn't hear me, did you, Lydia?
I'm not worried about that at all.
It's just middle child. I think Greg's taller.
You almost saw it. Oh,
The youngest man was a foot shorter than me.
You think Grant passed you?
Yeah.
I don't think he's that tall.
I should help.
Yeah, but aren't you 5'11" or 10 or something?
Yeah, but he's like,
So he'd have to be like 6 foot.
he's
not
6
big.
foot.
Nah.
Dude, he's not
If
6
you see
foot.
me like
Grant
by
is
him,
not
like
6
right
foot.
by him, he's like as tall as
He's probably, he might be tied.
me. Yeah. Yeah.
What?
Yeah. I'm not shocked. I wouldn't be shocked if he is. He's
All
like,
right.
he's like right there.
When did he get tall?
I don't
Since when?
I don't believe her.
He shot up though. He was short last year.
Okay. 13. What's the probability of getting purple or orange?
8 out of 14.
Yeah, there's 3 purple, 5 orange, so that's 8 out of 14, which equals 4 out of 7. What's probability of getting purple followed by orange and replacement? So you're putting the token back in. So what's the probability of getting purple on the first draw? 3 out of 14. That's event number 1. What's the probability of getting orange on the second draw? 5 out of 14. Because you're putting the token back, the probabilities aren't going to change. Unlike number 16 where you're keeping the token. Probabilities are affected, they're dependent events on 16. So what are the chances of these both happening like this? Times, right? If you want 2 events to both happen, you multiply the probability, or 3 or 4, however many events to both happen, you multiply the probability of their events. So it's 15 out of 196. Okay, on 17 are successive rolls of a number cube. That kind of bugs me that they say that. Independent or dependent. So when you roll the first die, is that going to affect the roll of the second die? No. So they are not dependent on each other. So they are.
What is it? I was thinking alphabet. Okay, alphabet.
Who has your brain cell?
I don't know. Sam's in the joke now.
Yeah, you don't want like.
It's probably wherever Lydia's hiccup list is.
Yeah.
Like hiccup telly.
It's been going for longer than
Okay, 18. What was the difference between inclusive and mutually exclusive? So inclusive events are things that can happen at the same time, like there's overlap. What was the example I used the other day? It was like
You can't be born in 2 states.
16 and a sophomore. Is that what it said?
I was
Something like
just
that.
thinking that whenever he said you weren't from like South Dakota or something, you had to have fit.
Well, I didn't notice you throw a fit, Katie.
I am from South Dakota. You didn't ask.
I just assumed. I mean, what are the chances that somebody else?
We're in South Dakota for Jewish, right?
Brookings.
Would you?
It's actually right
It's not.
next. One
Why does it matter? We don't know
picture with
anything
my
about South Dakota.
grandparents. Just like, you know, I'm with their grandparents. I'm like, am I seeing this right?
Is those the grandparents that did that TikTok with you?
Yeah.
How'd you figure out they were Trade's grandparents?
My mom, she said, those are Trey's grandparents. And I said, okay, let's get a picture.
How? What?
So we just at the same church as them, or okay? How confused were you?
It still
when you
seems
got that?
random. I mean, I know there's not a lot of people in South Dakota, but still, it's kind of weird.
Our parents went to the same youth group or something.
Oh really?
I don't know.
So, like, your parents
And then
knew each
Mr.
other?
Totino was the youth pastor, I think.
No
way.
He's also
Are you
from
kidding?
South Dakota.
Are there like 10 people in South Dakota?
How old is he?
I don't know. He doesn't look that old.
I'm not gonna guess it. Okay, anyway, I can't remember what the example was. The states thing,
Yeah.
like born in Oklahoma, born in South Dakota, those are exclusive because you can't be both. So if they do overlap, like being 16 and a sophomore, that's inclusive overlap. Those were the harder probabilities because you had to subtract out the overlap. You guys remember that? No? Well, let's look at 19. Oh, 19 and 20 are kind of...
My kids were born like that.
My kids.
That's what I was thinking of. My kids were born
My
like that.
children were born like
It's
this.
just that I was like, well, I'm screwed.
Okay, on 19... We'll probably stop at this second. You guys are about to leave, aren't you?
Oh, right.
Well, maybe we'll save it. Yeah, we've got that huge table thing to make, but I think we're over halfway. Well, it's not number 19. It's not the table.
Watch you some homies.
Yeah.